now we ran into a couple of issues with trying to set this job up to do the turret, and it behaves a lot different than the Hardinge. Let's just put it that way. So basically, when you move the turret closer to here, and you move the carriage in, when I take the turret stop off, I'll move the carriage far up, but I need it to move. With that, when you move the turret closer into here, it starts hitting the cross slide. So you have to kind of set this up almost with the cross slider part in here. I was trying to use the turret and use the carriage to move back and forth, kind of a combination of both, and it wasn't really happening. And I had to move on it. I'm sure I could spend a little bit more time and kind of figure it out. So basically, what I'm trying to say here is, I'm doing these parts in a two-step approach. So the first step is I'm going to do all the turning. I'm going to face it, I'm going to cut the shoulder and part it off back here without using any of the turret tools, right? Because that's what I'm doing. I'm turning. So I didn't want to use any turning tools on the turret because I have to dial these in, and I have a very, very small tolerance. I have a 2/1000 tolerance on these parts because they're actually Backlash nuts for a small desktop lathe. So with that, I wanted to do everything again, like I said, with the carriage. So using the turret stop over here, it allows me to do a few operations. To face off to length, I'll turn my diameter down, and then I will part it off. We're doing a little bit of filing, we're putting a little tiny recess down where the shoulder meets, and I'm accomplishing all of that using this turret stop. And then the second operation is, when all the pieces are done, I'm going to put them back in the collet. I'm going to move this out of the way. Move this out of the way. I'm acting like I could take it off, but this will be tucked in. We're going to move the turret in, and all we're going to do is we're going to drill our hole, and then we're going to tap it. And then the third step, obviously, is to do the milling. There's some milling operations that need to be done on these parts. So this is going to be a 3-part video to show how these pieces really come together. So really what we had to do first was I positioned the carriage and I pulled the work out and I locked it in place. I faced it off, the carriage is locked, I faced it off, and then I basically put a stop here and set the stop to the carriage. So now we have our piece basically sized. So then the next operation is I need to come down about 9.5 millimeters of travel for the shoulder, and the diameter really is freeform here. I'm doing this by hand. I'm actually taking little bits, miking it. I'm sneaking up on it, and I'm getting them perfect. So this is just normal lathe operation here. But the stop, the Z-axis stop, it's a lot of measuring. We sneak up to it, we get our measurement perfect, and then again we change to another stop on the turret, set the stop for it, and we have our length of travel set then. And then the third operation is cutting a recess. Every tool is going to leave a little tiny bit of a radius when it meets a shoulder. So you really want to plow into, you want to get a sharp point, and let me see if I could show it. I have this guy right here. This is just a high-speed steel tool that I ground with a very, very sharp point. And that basically goes in and it cleans up the radius out of that shoulder. And then the fourth operation, is that the third operation or fourth? Whatever, the next operation will be to move this into its location and then part it off. And obviously we're taking burrs off, we're filing and stuff like that. So that's really phase one. It's just the lathe work. Again, I have 60 pieces to make. The Hardinge over there is all tied up. This would have been a perfect job for the Hardinge, or if I had a little bit more experience with this. But I got to be honest, and I can't pretend like I'm proficient in this when I'm not. The Hardinge, like I said, I could have probably set that up real fast and done it all, but it's set up for another job at the moment. So we have to make do with what we have, and because we have a deadline, got to move quick and got to get the parts done. It's a batch of 60 parts, so it's not the end of the world, and it ain't going to take forever. So it's just faster to kind of just do it in this couple phased approach and just knock it out and get it out to the customer. So I'm going to show you how I turn this first phase right now. The first step in getting this sized is to, first we're going to set our turret to the facing. You know, I have these labeled with tape. It's just easier and faster to switch around, and you know, you cut down on your chances of making a mistake and setting the wrong stop. So I set it to the facing stop. And then I'm not going to do it now because I did it off camera before I started filming. I will literally pull this out to this tip a little bit past, you know, and play around with it, lock it in, just so I have a couple of, you know, 10, 15 thousandths or whatever to face this off. So let's go for it. So we faced it off, right? So now I turn it over here to the next one labeled turning. Set my dial, and then we go for it. Now I'm just watching down here. I'm watching the stop. I'm watching both, and I just stop them right before. And then I hand feed that last part in. I change over here on the dial. If you'll notice, I have some, it's probably out of the camera's view, but I have some pencil lines here. And every 50 thousandths, I'm taking 50 thousandths cuts. So every 50 thousandths when you move the dial, I have a nice big heavy pencil line just to make it easier and faster. Because when you're doing 60 of these, and each part takes approximately 8 cuts. So it helps facilitate the speed. Now the material we're cutting here is 510 phosphorus bronze. It's hardened bronze. And it has its own characteristics for cutting. We'll just say that. Its own special properties. Alright, so we're coming close now. We're going to be getting closer. Alright, now I'm coming in 5 thousandths under, just to take a light cut. It kind of acts like as a spring cut and a sneak up cut at the same time. And then I come down to its final dimension. All this has been preset on the dial. last cut. Now it's going to produce some fuzz, some chips on there. But what I come in here, now I'm trying to squeeze in here. Come over here, I'll take off any burr. And then I'll just lay the file on here. It just removes all that fuzz. All right. We're looking for 314 thousandths. We're at 312.5. So, you know, we have a 2 thousandths tolerance, so we're within tolerance on that one. Although I don't really like it to be that close, but it's still in spec. And now the next operation we're going to do is we're going to cut that little relief in there. So now I turn my turret stop over to recess, back it out a little bit. Lock it down. And we're just going in enough. Get that out of there. Now again, that one as well will leave a little hair in there. So I'm just using the Scotch-Brite and it just cleans up the face, removes any of those kind of chips out of there. And now the last operation that we do is parting. Move our turret stop over to part. Bring it in place, lock it down. A little bit of oil. All right. And you probably just heard me toss that into a cold, little cold bucket of water here. Just cools it off so I can handle it a little bit better. And then here you go. Here's the finished product. Let's go over to the bench and we'll go take a look at it now. Before we drill and tap the hole, this flange here needs to be sized properly. So I have it dialed in, basically just using a stop, and I use the parting tool, and we'll come right in. Just size it. Hit the edge with the file. Go. Into the pile it goes. Okay, so you're seeing this in real time as I'm experiencing it. The turret has failed me. The turret is in bad shape. One thing about a turret is it's matched for the lathe when you buy it from the factory. Again, if you buy a turret after the fact, it comes with I don't know if the turret head is got no holes or just small pilot holes, but you're supposed to bore it. You're supposed to hook a cutter, you know, a drill into here, and then use the turret and bore those tool holders to the lathe. So it's a matched set. The turret that I have is totally not matched. It's just very problematic, so I cannot proceed on the South Bend. I started using the tailstock and drilling this bronze. The tailstock is a little bit bad too. The tailstock is out. It points down, and it almost seems like it's pointing, you know, towards the operator over here. So a few of them I was kind of lifting up on this to try to help the drill find center, and I just gave up on it after 2 test pieces that I had. So luckily, as you know, luck would have it, I had one open tool holder on the Hardinge, so to not mess up the Hardinge setup for the other job that I'm running, I mounted a drill inside there, which, you know, the turret works beautifully, and you know, you can move the floating drill heads around. So that's what I did. I set it up over there, and I'll take, and basically what I did with this first, before I go over to the Hardinge, is I just used a little tiny center drill, and I just center drilled each one. All right, because the center drill was actually working. It was real short, it was stubby. I moved it in close, and it didn't have any, you know, the tailstock didn't have any chance to hang down. So I didn't film any of that. I mean, I was just pecking 60 pieces and center drilled them. So we'll go over to the Hardinge, and I'll show you how I'm drilling them out. So with the beauty of the Hardinge, I can mount one of these drill holders here, and they're very adjustable. And not only that, this turret is perfect. So I loaded up a new gearing, I guess that's how you pronounce it, gearing 5.5mm drill, and it's going right through this bronze like no one's business. It just goes super easy right through it. So let's do one. We have three pieces left. I'll show you how I do that as I'm maneuvering underneath the camera here. So forgive me if it's all right, there we go. Okay. Turn on some oil. And peck away. You got to be careful so you don't blast through the other side, like many of the pieces I have done. Just like that. Shut it off. Over here. Pop it out. And there's our piece. All done. 2 more to go. Alright, we are set up for the last operation, lathe work operation of these parts here. So I was using, you can see over here, it's not quite yet out of the frame. I was using this tool holder, which was a blank one, to do the drilling. But now when I need to use this, this is called a TT head from Hardinge, and it's a male tapping head. It wouldn't fit over there, so I had to cannibalize one of the tools. I had to take out the center drill for the other job that I have set up here, which is no problem. It's just a center drill, easy enough to put it back. So this TT head here basically holds a tap, and then you feed it in, and it threads. And when the turret hits the stop, this head over here, well, I guess I just have to get my hands dirty. This head has like a little spring here, so it will thread, and when the turret stops, it will keep threading and pull out, and as it pulls out, it becomes disconnected and spins freely. And then what you do is you just slam it into reverse to reverse it right out. It couldn't be easier. It really couldn't. It's a pleasure to make these parts. So I'm going to show you how we do them right now. So we load it in, lock it in. Here we go. Make sure this is seated correctly. Now I have the oil just pouring right on there, and all that does is that's actually like a pre-oil. So I just come in here. Now you see it pops out. It's spinning free. I just slam it into reverse, and it just backs it out. We're done. Pop. I wanted it to pop right out. Sometimes they pop right out into your hand. It's very oily, and oh, there it goes. Now that we got the Hardinge indexer all dialed in, and through the magic of video, I'm all the way at the end of the job now, and I've saved the last piece to show you how we did this. I don't think you wanted to sit through 60 pieces and a few test pieces. So basically, you know, we used our pin, got it all dialed in perfectly, and then we have to calculate now an offset for the flat. So this is what the pieces are going to look like when they're done, and we have to mill 2 flats here, and then plunge down and cut these 2 little notches in here. We'll lock it down. Now this is using a 5C collet, if you weren't aware. These Hardinge indexers. This thing is, let me get the name on this one. This is an HV4N. That's what this thing is called. It accepts it. It's got threads here, and it'll accept the chuck, and it goes vertical and it goes horizontal. And there's plenty of videos out there all about these things, but they're indexers basically. They have little screws on this plate that sits, that sits underneath it, and you can set those screws to different index points. I just have this set for 180 degrees because I have, everything that's done on one side is done on the other, so it really works out great. And another really nice thing about this that might not have been apparent in the setup is that this whole indexer can be turned this way. It doesn't, you don't have to worry about lining it up. All you have to do is just, like we did, is just center it up with your coaxial indicator or another indicator and it's good to go. Wherever the 0 point is, if you flip 180 will flip just normally. So the offset now that we got to go on this is going to be, actually the flat is going to be 9 millimeters. I'm sorry, 10.5 millimeters. Okay. So obviously we do a little math. We divide that in half and then add in the half of the cutter. Blah blah blah. So basically we're moving this thing off center to 7.35 millimeters. So let me do that now. Let me just get this kind of set really quick. So now I'm just going to use my power feed and just kind of go through it, and I'm going to be blowing the chips out a little bit with the air just so they don't clog. Got our height set up. Here we go. Very slow speed because this metal is grabby. So I'm just shooting the chips out of the way just so they don't clog up. Every now and then I just... you gotta love my little pancake air compressor there. Alright, so I'm gonna go back and just bring it, because what I want to do is I want to climb cut this when I go through. And even though I just went back and and hit it conventionally, on the return, it's leaving a very, very nice finish. What was happening was when I was cutting this conventional, it was actually bowing in, because this little stem is sticking up a little tiny bit. So believe it or not, it has a little bit of wiggle, right? So the conventional cutting was pulling the piece into the cutter and then letting it go, creating this little curve. So I'm doing some climb cutting on the other side. So we simply index it to 180 degrees and start the process all over again. We're running about 1700 RPMs, and this is a 4.2 millimeter end mill carbide. Alright, now what I'm going to do is I'm going to move this to 0 and bring it to center for the slots, or the notches. And then the X dimension is going to be 8.975. 8.975. Now, with some experimentation, I snapped 2 end mills already. Just plunging right down. Don't be fooled that a soft metal like bronze is going to cut like butter. I mean, it does cut like butter, but a lot of buildup happens on the bottom of that end mill, and it gets clogged, and then it binds up, it heats up, it expands, it binds, boom, and you have a snapped end mill. It happened twice already, so I found a good way of doing it. I peck down about anywhere from 10 to 15 cuts, and I keep using my toothbrush to remove any clogged chips, and it's proved perfect solution. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cuts on that one. Come over here, index it, and do it again. And that's really it. You know, it's a very, very gentle touch. It's all about feel. You could actually feel it. You could feel the quill dropping down as it's cutting. And it's very, very smooth. And instantaneously, you'll start to feel a little bit of like rumble, like, you know, like when your car's going off the side of the road. And then you know to back off on it. So it's all about feel. All right, let's pop these little tabs. Looks like I could have went deeper a little bit, but there's our part. And there you go. And into the pile it goes. Actually, this is a test piece because it has no threading in it. So, you know, I've done all my pieces, but I had a couple extra, you know, just to show you. So there you have it. There's a completed job, you know, minus any little deburring that I got to do. But that's it. That's another one in the can, and we'll get the invoice out to the customer just as soon as we ship them. So thank you guys for watching. I hope this was somewhat informative, you know, giving you a little peek into, you know, a regular real life production job here at Maple Lane. Thanks, guys.